So far, we have been looking at equations of rational functions and determining asymptotes, but actually now we're going to be finding the graph of those equations, finding the graph of the equations using our asymptotes, using our intercepts. So we have a few steps that we need to use in order to draw these graphs. I wrote them out here. They are in your book on page 234. So let's just go ahead and start straight away and draw a graph. Our first equation, we have f of x equals x minus 1. First thing we always are going to do with these equations is factor. So denominator factors as x plus 4 times x minus 2. The first thing you want to check is to see if anything cancels out. If it cancels out, you can cancel it out. We'll actually talk about what's going to happen in that case later on. But cancel it out and then write it in lowest terms. Write your fraction in lowest terms. So that's the first thing that we do. Generally, you will have to identify the domain. I didn't actually specifically ask you to do that in your analysis, but usually you have to do that. The domain you're going to find, remember, when your denominator is not equal to 0. So we end up finding that our domain is all x, such that x is not equal to -2 and x is not equal to +2. That's the first thing that we usually need to find. So then the next thing we're going to do is we are going to find our intercepts. So let's start with our y-intercept. So to find your y-intercept, you are going to set x equal to 0. And so I'll go ahead and do that. I'm writing it as f of 0, that's my y-intercept right there, is equal to all of this. Usually it's easier if you use the equation after you factor it. So you should end up getting, hopefully, 1/4. So my y-intercept is at 0, 1/4. My x-intercept, it actually looks a lot harder than it is. So remember, for the x-intercept, you're going to set the y equal to 0, or we set f of x equals 0, if you want to think of it that way. So I'm going to set this equation, x minus 1 over x plus 2, x minus 2 equal to 0. This looks complicated, but actually, if you have a fraction and the numerator of that fraction equals 0, the entire fraction is going to equal 0. So what I'm just going to do is ignore the denominator for now, set my numerator equal to 0. So I end up getting x equals 1, and then I'm going to find that my x-intercept is at 1, 0. When we have a function, we can have multiple x-intercepts, and you often will, but we're only going to have 1 or 0 occasionally y-intercepts. The next thing that we're going to do is find our asymptotes. So let's start with our vertical asymptotes. Remember, to find the vertical asymptotes, you need to set your denominator equal to 0. And when we do that, thankfully it's already factored, so that part's been done for us. We end up getting x equals -2 and x equals +2. Do not forget that for vertical asymptotes, you need the x equals. For horizontal asymptotes, you are going to want the y equals. So my horizontal asymptotes, I'm actually only going to have 1 here. So the degree of the numerator is equal to 1. The degree of the denominator is equal to 2. Since the numerator degree is less than the denominator degree, we have a rule for that, and we just remember that it's y equals 0. You don't actually have to do any math for this one. So the last thing that we need to do with these is draw our graph, and that's actually the hardest part also. So I'm going to put in this stuff I know. I know that I have an intercept at 1, 0, and I have an intercept at 0, 1/4. By the way, if you don't know exactly where 1/4 is, you can just kind of estimate it. The other thing I know is that I have some asymptotes. I have an asymptote at -2, x equals -2, and I have an asymptote at x equals +2. I also know that I have a horizontal asymptote at y equals 0. By the way, this is one of those rare cases where you will have a graph that intersects the asymptote. That's fine with horizontal asymptotes and with oblique asymptotes. So the next thing that you can do is you can do two things. You can either make an XY table or T-chart, whatever you want to call it, and then you can plot points. Or I'm actually totally fine if you graph this on Desmos. So now when you graph it on Desmos, you will find that the asymptotes do not actually show up on Desmos. That's fine. Asymptotes are more an aid for us as we're drawing our graph to help us know approximately what it looks like. So go ahead, and I want you guys to try to graph it on Desmos on your own. So if you draw the graph on Desmos, it does end up looking kind of like this. You will notice that the pieces of your graph kind of hug up against your asymptotes, which is what you want, with the exception of that intercept at x equals 1. They don't touch the asymptotes. They get closer and closer and closer and never touch. But this is what your graph looks like. For this class right now, you've been using a calculator for everything. I'm totally fine if you use Desmos to graph it. I do want you to know kind of how to find the asymptotes and how to draw them and how they're going to affect your graph. But because of the situation that we're in, you're welcome to just graph this on Desmos and use that to check your asymptotes, use that to help you out. So here's another one. You're welcome to try it on your own. So let's go ahead and start by factoring. We get x plus 1 times x minus 1 all over x. You'll notice that nothing cancels out, so I'm not going to do anything on that part. I am going to find my intercepts. So to find my y-intercept, I'm going to set x equal to 0, but actually, if you set x equal to 0, you get a 0 denominator, so I actually don't have any y-intercepts. To find my x-intercepts, I am going to set the entire equation equal to 0, but it ends up being that I just set my numerator equal to 0. I do have two x-intercepts. I have one at 1, 0, and I have one at -1, 0. To find my vertical asymptotes, I am going to set my denominator equal to 0. And since my denominator is just x, I have a vertical asymptote at x equals 0. To find my horizontal asymptotes, I look at my degrees. I actually notice that the degree of the numerator is 1 greater than the degree of the denominator. That means I have none. However, I do have an oblique asymptote. So to find that, I need to use polynomial long division. So that one is going to look like this. This one, thankfully, is not a terribly hard one. I start by doing x squared divided by x, and that just gives me x. And then I'm going to subtract this. I end up getting -1 as a remainder, and I can't divide x into that, so I just end up with an oblique asymptote at y equals x. So now you can use everything that you have to draw your graph. So I know that I have this oblique asymptote right here. I have a vertical asymptote at x equals 0. I have intercepts at 1 and -1. And keep in mind that your graph will kind of hug against these two asymptotes. So this one is going to go and get closer and closer to x equals 1. This will go and get closer and closer to y equals x. The other side, same thing happens. Looks kind of like this. By the way, if you draw this on Desmos, this shouldn't have a bump in there, it should be nice and smooth. If you draw this on Desmos, you will notice that there are no asymptotes on there. That's because the asymptotes are not technically part of the graph. Like I said before, they're just an aid for helping you graph it. I do recommend that you check your answer on Desmos for all of these just to see what it looks like there too. So our next thing that you're going to see is what we call a hole in the graph. That is going to occur in places where your denominator equals 0, so it's not in the domain, but you get a factor that actually cancels out. So let's go ahead and start by factoring this one. If you factor this, you end up getting 2x minus 1 times x minus 2 all over x plus 2 times x minus 2. And if you notice, the x minus 2's cancel out, so then we are left with 2x minus 1 over x plus 2. So now the x minus 2 doesn't just go away and nothing happens to the graph, but that almost is what happens. So I'll talk about the hole in just a second, but first let's go ahead and take our simplest form and we'll use that to find our intercepts. So I can first find my y-intercept by setting x equal to 0. I'm going to find f of 0. I end up getting -1/2, so I have a y-intercept at 0, -1/2. I have x-intercepts where my y equals 0, so I'm actually going to set my numerator equal to 0, and I end up getting x equals 1/2. So that gives me an intercept at 1/2, 0. Now I can find my vertical and horizontal asymptotes. Vertical asymptote occurs where the denominator equals 0, so I get x is equal to -2. In this case, I do have a horizontal asymptote, and you'll notice that I have the same degree for the numerator and the denominator. I'm going to add a 1 in front of that x, so I do the leading coefficients and I divide them out. So my horizontal asymptote ends up being at y is equal to 2 over 1, which gives me 2. The other thing is that I have to account for this factor that was canceled out. So I know that x equals 2 is not in my domain, so I have a hole at x equals 2. And what I actually can do, I can find the specific point where there's a hole by taking 2 and substituting it into this simplified form. So when I do that, I do usually end up getting a fraction. It's rare that you do this and you don't get a fraction for your second one, but it's fine. So I do have a hole at 2 3/4. There's not a point there, there is a hole there, and I'll show you what it looks like in just a second. Now I'm going to use everything that I just found to draw my graph. I know that I have a y-intercept at 0, -1/2. I know I have an x-intercept at 1/2, 0. I have a horizontal asymptote at y equals 2. I have a vertical asymptote at x equals -2. So now I can use those things to help me, but there is one more thing, and that is my hole is at 2 3/4. Please do not draw a point at 2 3/4. You're going to have an open circle there. So that's my hole in the graph. It looks like that. So I will tell you, and I'm going to warn you, if you graph this on Desmos, you most likely will not notice the hole unless you actually trace along there. You'll notice that if you put in if you have x equals 2, it'll just give you a blank space for y. But it's not easy to see these holes on the graphs, so you are going to have to do this stuff on your own. So then my graph ends up looking like this. You'll find this is not quite a perfect graph. It's a little lumpy looking. It should be smoother than that. And then this side is right here. Again, feel free to use Desmos for that. If you don't use Desmos, you can always do an XY chart. You can substitute in like maybe -3, -4 are good points to try just to kind of determine where that other part of the graph is. So this is it for my graph. Just make sure that you get that whole, make sure that you have your asymptotes, make sure that you have all of your intercepts.